roll up your sleeves, join that
Yeah.
team, or find a way to be a part of that team, and then try to make your boss and your boss look super successful with analytics. And a lot of times it means biting off small chunks at a time, quick wins,
Mm.
rather than trying to hit a home run with analytics.
Welcome to the Tech Guide podcast. I'm the show's host, Ryan Atkinson. Today we have Dean Abbott on the podcast to talk about what goes into a typical data model test and analysis, real project that he's worked on with the IRS and the US Navy. This is a fun conversation to talk about analyzing grit and like physical attributes of these seals. And then we also close with where you should look at if you want a career in data analytics. Welcome, Dean. So excited to have you on.
Thanks for having me. I'm really looking forward to the conversation.
Yes. And you are like a mastermind, a wizard in all things data analytics. You've been in analytics for like over 20 years. So I'm just curious, like the history of analytics and like how the perception of like the world has changed on on data analytics since you got started.
Yeah, it's interesting because I didn't start my career planning and going to analytics. So I was a computational math undergrad, applied math grad student. I got a master's, and I was always interested in the analytics side. I mean, back to when I was like a kid playing baseball and computing my own batting
Interesting.
averages, things like that. But when I started my career, it was so useful
Mm,
and practical. And this was back in the 80s. This was like 35 years ago. But the core methods that I started learning at that time really persist to this day. So in one sense, not much has
interesting.
changed over the last 30, 40 years in analytics. You still have basic statistical methods, and those go back 100 years. A lot of the machine learning algorithms that are commonly used today, they've been around for 30, 40, 50, 60,
Really?
100 years. So a lot of things are the same, though there are a few new things, and we could go into some of the new things, but the primary difference between doing analytics now and then is the size of the data you can analyze is much bigger today because of
Mm,
improvements primarily in hardware. Software improvements as well, but it's primarily hardware. You can just crunch a lot more data now, which is fantastic because that means that instead of trying to squeeze your analysis into a small size, you can like load into an Excel spreadsheet, a few thousand rows or something like
yeah.
that. Now you can analyze millions and tens of millions, gigabytes of data all at one time.
Interesting. And yeah, how small was the sample size back in like the 80s and 90s of like data? Like, can you give us like a deeper comparison on that?
Oh yeah, it was not uncommon to be looking at hundreds to a few thousand records. In fact, I kind
Interesting.
of crashed at the University of California, San Diego, which is close to where I live. They have a supercomputing center, and I crashed a meeting of statisticians. These are famous statisticians. I don't want to embarrass anybody with naming names, but if you're in statistics, you would know who these people are. And one of the
Interesting.
questions they're asked, and this is in the 90s, what's the largest data set you've ever worked with, the largest number of rows? And for some of them, it was 1,000 records or 10,000 records.
Interesting.
And so that gives you context about what the way people were working. And statistics back in that time was really geared around small sample sizes. Like, how do you wring out as
Interesting.
much information from 100 records or 500 records? Now we can, because the data size is so big, those constraints really aren't applicable anymore. And we can apply other techniques that don't require all the strong assumptions that statistical methods require us to use.
That's super interesting. It sounds like a lot of the foundation, as you said, but data sets are a lot bigger, but the foundations is still there and it's still applicable. I'm curious, can you dive into like the foundations of like statistics and data analytics?
Yeah. So some of the foundational things, everybody who wants to get into analytics should understand some like basic statistics and have, even if
Interesting.
you don't understand the math. No, I am really not talking about the math of it. The math is interesting. And the way statistics is usually taught is very mathematical. I'm talking more about the intuition around what happens to the data when you compute these metrics. The simplest ones, things like means, like the
Mm,
average, and what happens to the average value if the shape of your data is weird. Like most of
interesting.
the one of the core principles in statistics, there's theoretical reasons for this, but is this idea of a normal distribution or Gaussian distribution. And that normal distribution is there and like I said, for theoretical reasons. That's the way data tends to operate. That's the way it tends to be distributed. But it's not always like that. So if your data isn't of that shape, if you've got weird values, like way out there, you can't see my hand out there, but outliers, how much that influences what that central there. The idea of the mean is what's typical, what's in the
Yep.
middle of the distribution. And so, but if your data shape is odd, then that average value does not represent the middle anymore. And you need to
Interesting.
think about what other representations can you provide for the data? How can you change the data so that it complies with these assumptions? Statistical methods, whether it's linear regression or like principal component analysis or any of these kinds of techniques, they assume that shape of the data is normally distributed. And that's what gets people into trouble first, especially with smaller
Interesting.
data when you can have weird distributions. If you don't comply with that shape, all those metrics like a mean does it's not representative of what's going on in the data. So that's
Interesting.
one of the things is knowing how you can be fooled by these metrics.
Interesting. And so, like, how are some of the ways, like, when you're analyzing data like this, like, how are some of the ways to set those benchmarks and know, like, how do we check ourselves along as we go when we're building out like a model like this or some sort of analysis?
Yeah. So and we may revisit this later, so I'll say it now. Well, one of the frameworks I like to use to describe analytics, and
Mm.
when you're a professional doing analytical based projects, I usually think of it in terms of 6 stages of what you're doing. And the framework that I use, it's not because it's unique, but it's written. It's called CRISP DM, CRISP hyphen DM. So it's the cross industry standard process model for data mining. And so the stages are business understanding, data preparation, fixing data, cleaning data, the modeling, evaluation, and then final deployment. So in the early stages, data understanding, that's where we use a lot of these statistical techniques to get a lay of the land. What does the data look like?
Yep.
What are the characteristics of the data? So you compute something like a mean to tell you, well, what's typical? Because the question you want to ask at that stage is, does this make sense? So let's say you're a nonprofit, and
Yep.
which I've done a bunch of nonprofit modeling, and you want to know what's the average age of the donors to my nonprofit. And if the average age is 120 years old, then okay, that we know that's not realistic. That's not
Yeah.
right. There's something going on here. Note to self, look at the data, understand why it's so off, why it's so weird.
Interesting.
Or if the average age is like 10 years old, there's something else. Because, like, for example, something that might happen, maybe for half of the data, you don't have an age. And so it's called missing data. And let's say somebody on the database side said, hey, we can't have missing data. Let's fill in those missing values with a zero, which shifts the mean down, which makes it unrealistic. So, but sometimes you don't know as the analyst, you just get a pile of data. You don't know all the stuff that's been done to it. So at this stage, you're just trying to understand, what does it look like? Does it make sense? Can I see some weird things in the data that I'll need to fix later? So that's kind of in terms of core fundamental things. That's the first things we always do. You should always do with the data is just summarize every data element you're going to use in your analysis to make sure that it makes sense and it doesn't have weird things in it. Because there's like one of the quotes I that gets that got picked up a lot is it's a flip of a George Box quote. The George Box quote is all models are wrong,
Yeah.
but some are useful. What I usually say to change that is all data is wrong, but most is useful because
Mm.
data always has problems with it. But usually we can fix it to a point where it's better than nothing. And that's really what we want.
Interesting.
We want to improve business practices with data. Doesn't have to be perfect, just has to be better than what we had before.
Yeah. I'm curious when it comes to like a business practice perspective on like the data that companies should be crunching. What is like some sort of practice that you think no matter the industry, like you should be crunching? It might not be, might not be that blanketed, but like, is there some sort of framework that you think any organization should implement when like analyzing their data?
Yeah, and that's why I like this CRISP DM process model I was describing
Yeah.
before, because these 6 stages are common no matter what kind of analysis you do. So
Mm,
the first stage, for example, is business understanding. So it's defining the problem you're trying to solve.
yeah.
And one of the biggest misses I see with analytics projects is there's a disconnect between the business and the analyst. So the
Mhm.
business will
Mm,
describe, they don't know necessarily how to describe the problem in terms that the analyst can understand and use. So
yeah.
what I usually try to get them to do is describe what you want to do in your language. Let's
Mm,
say for this nonprofit, they want to, well, we want to know which donors who haven't given in more than a year are recoverable so that we
mm,
can try to recover them in a cost effective way. Okay, that's great. Now, that's not a modeling project that I can take as an analyst, but
yeah.
at least gives me an idea of what they want. So then the question is, how do we translate that into a quantifiable thing? So, for example, in that situation, maybe do we have in the data examples of lapsed donors who have been recovered and other lapsed donors who have not been recovered? Okay. And then we can create a column in our data that says recoverable, not recoverable. And then we can build a model to see if we can understand the difference between the recoverable and the unrecoverable ones so that we can score every donor so that we can identify which subset of donors we should try to recover. And so you can see there's a whole sequence of steps, but that's a translation between what the business is trying to accomplish and then what you could do with analytics.
Interesting. What I like about that is like getting the alignment on with like the business objectives, but like the analyst be like, I don't really know what that means, but like I can kind of like take these steps to identify the problem and then give you the solution from that.
Yes, and that's always a conversation because the reason why I say this is where most projects fail
Mm,
is the business can't describe in quantitative terms. They can only describe in qualitative terms. And the
yeah.
analysts, sometimes super smart analysts, kind of they think they understand, but they really don't. And so I see so many times when when some organizations will throw the data over to the analysts, say, "Hey, do something magical with this data," and
Yeah.
they build incredibly accurate, interesting models that solve irrelevant problems because they don't
Mm,
know what they're really trying to solve. So in the end, the director or the VP level, they show us what you got, and the analyst will show them, and they'll say, that has nothing to do with what I need. And they said, well, we didn't know what you wanted. But so there, that disconnect really bites you down the road. So there has to be the conversation, connect these together. And there has to be really regular feedback, especially the first time you're introducing more advanced analytics to the
yeah.
organization, because you're trying to train each other on how to do analytics.
Yeah. That's what I'm also curious about. So let's just say you're aligned on the objectives, you run the models, it turns out great. Like, yes, like thank you, like this is perfect. But how do you then present that data? Do you use like any storytelling technique or how do you effectively translate this data to someone that might not speak data?
And I think it's good the way you described it there, storytelling,
Mm,
because the data is telling stories about your business process. So again, if we go back to the nonprofit
yeah.
example, what is the data telling? The data is telling stories about the way donors behave. And the story we want to tell is which donors are lapsed donors because of something which we don't understand, but
Yeah.
their heart is really with the organization and they'll come back if you just nudge them a little bit and if you send the right message to them. So that storytelling is important. So that's why defining the problem initially is so important, but also then for the analysts, what should they be communicating back up? It's not just how accurate the models are.
Mm,
Or in this case, there are two things I think in particular the analysts need to percolate back up to the business side. Number one is how will these analyses or these models change behavior? How will they ultimately impact the nonprofit? And in this case, it's what kind of revenue? What's the net revenue I expect when I deploy this model? That's the language that the business will really want to know, not what
yeah.
percent correct classification do I have? Or what's the average
Yeah.
donation
Yeah.
amount? No, we want to, how much revenue is this going to generate? The second thing they'll want to know is what's driving the high likelihood to be recoverable donors. So
Interesting.
what characteristics are there? Because You could say, hey, it's these particular characteristics. And maybe one of them is, well, those in this particular zip code, that's really the key. And they'll look at you and go, wait a second, why does zip
Mm,
code matter? Why is zip code even in this? We want to be careful of things like zip code. We don't want to do redlining. And then the analyst is going, uh-oh, but in order to explain why the models are good, to describe which characteristics, which attributes are driving the model decisions, that will help give confidence with the decision makers that it's doing a good thing. And the ideal is like 80% of what you tell them, they say, yeah, of course, I didn't need a machine learning model to tell me that. But then every once in a while, you want it to describe something and they'll go, huh, okay, that makes sense. I wouldn't have thought of that, because you wanted
yeah.
to do the obvious, of course, and then the not so obvious to show that it's finding something in the data that's buried in the data, one of those hidden gems that they wouldn't have found if they had just tried to do something in an Excel spreadsheet themselves.
That's super interesting. And then once this is all, so you have the model, you have the objective, you are able to present this, but how are some other ways do you like continuously like evaluate the performance of the model, ensure that it's correct all the time? Maybe I don't know if all the time's a stretch, but like how do you continuously update the model, make sure it's right?
It's It's such a good question. It's almost like you've done this before. The way you're describing that's exactly the right question to ask at this point, because a lot of organizations, once they build a model and then they deploy it, and this is generating, like in this donation model, just to
Yeah.
pull this thread even more, you deploy it, and let's say every week you get a new list of lapsed donors. Because
Yeah.
let's say a lapsed donor is someone who hasn't given in a year. So every year you just get an updated list, you score them all, and then you decide which ones you're trying to recover. So a lot of times they deploy it and they set it and forget it, like the
Mm,
infomercials.
yeah.
But the
Yes.
problem is this: over time, maybe patterns change, or
Mm,
maybe once you deploy the model, because you're capturing these lapsed donors and they're coming back and they're sticking with you, maybe you're getting a drift with the characteristics, the primary characteristics of lapsed donors that you have remaining. But it's just, so things are just changing. And it could be something just over time. It could be
yeah.
economic conditions are changing or something like that. So it's, we in technology terms, we may say it's a non-stationary process. It changes
Mm,
over time. So because of that, one of the things that a lot, maybe most organizations don't do, but should do, is this: you monitor your models. Are they doing what you expect them to do? Now, we know what they should do. As I mentioned before, we should be able to tell the organization, this is the revenue I expect to generate from
yep.
these models. So you deploy a list of like 100,000 lapsed donors, and we should know we should be generating an additional like 200 grand in revenue from this.
Yep.
Okay. Something like that. So what happens if now we're just getting 100,000? We're getting less than we expect. The question is why? And the analyst can look at that and show, oh, we're not getting the same recovery rate that we expected. And it's because of these variables are not doing the same things they used to do in the past.
Oh
It's
man.
time to refresh the models. And so that's what you can do. Then you can take all the new data that you've been getting, rebuild your models, get a new model score, get a new estimate of how well they'll do, and then deploy that. The more advanced and the more technically savvy companies will be doing this on a continuous basis. You've
Mm,
got your champion model that's doing something, and then you're constantly building a challenger model. And when the challenger model does better than your champion model, you swap them out. And then it's
ah,
your automatically, it's auto tuning the way you've deployed your models. And it's not technically difficult to do this,
mhm.
but it's something that it does take a little extra time and effort to work through. But if you can do that, then your model is always going to be doing well and doing what you expect it should be doing.
Yeah. I think it's just like really cool, like the updating that you like do. I like how you put it like the challenger model versus like the original model, and then just continuously updating that. I'm curious, like just from like all the projects you've worked on, has there ever been a time when like a challenger model came up and it like totally like blew your mind that like it changed? Kind of a wide spectrum question there, but like has there ever been a time that that's happened to you where it's like, holy smokes, this challenger model, I didn't think this is actually going to challenge it.
Yeah. I Maybe not exactly like that, but what I have seen happen is the way I was describing before, drift, where you see conditions are changing. And this
Yeah.
happens a lot with fraud detection, for example. So I was
Interesting.
building models for over 10 years with the IRS
So
and
cool.
looking at for large corporations non-compliance. And we would update models because economic conditions change.
Mm,
And if especially with something like fraud detection, you're trying to shut down non-compliance.
yeah.
And those patterns associated with non-compliance that the auditors are investigating, once they start doing that, companies get savvy to the kind of the triggering events. And then if they want to be non-compliant, they'll try to find another way to be non-compliant. And so then another thing will open it up. So the way I think of that, sometimes it's like you've got air in a balloon, you're always going to have non-compliance. But if
Yeah.
you squeeze the air in one part of the balloon, it gets pushed into another area. And
Mm,
so if there's an easy way for people to try to avoid paying tax, once you close that down, that loophole, then they'll find a new way to do it. So that means you just have to continually look at your models and update them so that you find those new patterns of behavior, different line items where people will pack money or different vehicles of, of siphoning off taxable income that is not legal that people will start using. Or when tax law changes, all of a sudden some things are shut down and other new things, unintended consequences of the tax law appear.
interesting. And I want to hit on that same thread because you've been like the president, the founder of Abbott Analytics, which has been really in years for 24 years or so. Some of the projects you've worked on, like the organizations, have been with like the US Navy, Intel, Los Angeles Times, Alaska
Yeah.
Airlines, IBM, Teradata, you
Yeah.
name it, you probably worked with them. Can you share with us like a favorite project, either like passion project or any just a favorite project that you worked on with any of these and just kind of what led up to it, what you worked on with it and like the end result that you gave?
Yeah. So one of those I just described with the IRS, which is fascinating to do that. But another one, you mentioned the US Navy. I was pulled in for a contract with the Navy SEALs for several years. And one of the things they were looking at was they're trying to identify what characterizes a successful SEAL. So especially in the late 2000 decade, early 2010s, there were new kinds of needs they had with the SEALs. But something else happened around that time too, which was interesting, is they had shifted the way they recruited SEALs from being totally through the Navy through these schools. So these are people who had been in the Navy for a couple of years and they're being funneled to the SEALs. They started recruiting guys off the street right out of high school and they saw rates of success dropping. Now,
Mm,
it's not a surprise that the rates aren't that high
yeah.
because the standards are so rigorous. It's brutal. So, but they would have like roughly like 25% success rate, something like that, but they're dropping well below that. So they wanted to understand why. So we're building models along those lines, trying to identify the characteristics of high schoolers and older guys that's led to success. So here's the part that was interesting about that to me is, of course, one of the most important things for all of these individuals is physical fitness. And there are these things called PST scores where push-ups, pull-ups, sit-ups, running time, and
Yeah.
swimming time, these five characteristics. And so you can measure, I mean, there are minimum standards, but people who succeeded tended to have better scores, more pull-ups, more sit-ups, shorter running, better running scores, better swim scores. But a couple of things are interesting. One is you didn't have to be excel in all of them. You had to excel in some. So you had to be really good in some pull-ups, push-ups. And even if your running scores weren't as good, as long as you excelled in one half, you tended to do better.
Interesting.
But we also were able to actually quantify how many more pull-ups, sit-ups, push-ups you needed as a high schooler compared to someone who's like 20 or 21. And so we never were able to get it exactly why, but I think the reason for that was when you're 18 and you're less mature,
Yeah.
everybody is being super stressed. Nobody has an easy time making it through training, getting to Hell Week, making it through
Yeah.
Hell Week. So because maturity is a factor, we hypothesized without having the data to prove it that what was happening is high schoolers being less mature needed to be less stressed physically than somebody who was a little older, more emotionally mature,
Mm,
who could absorb more of that stress level And so they didn't need to worry as much about the physical stress. So you can say that, well, they needed like another 2 push-ups
Hmm.
or 3 push-ups or something compared to a 20-year-old. So it's kind of interesting you could see from the data how those change. Now, these are, of course, on average influences.
Yeah.
It doesn't tell you every individual. So it's good at predicting an aggregate, but it's not going to be perfect because there's more going on than just the physical part. The psychological part, the grit and
Yeah.
persistence and all is important. And measuring that is a completely different story.
Yeah, well, that's of course, that's my follow-up question. How do you measure did you guys measure, like, psychologically or, like, intelligence or anything? And if not, that's fine, but, like, how would you even, like, measure something like that?
We did. So there's a standard score. There's an academic score across
Okay.
all these dimensions that everyone had to take those tests. And that wasn't super predictive in of itself. But something else we're starting to look at, and I know special forces in general have been looking at this more since I was doing this years ago, but this time was just beginning to gain some traction. There's a researcher, a woman named Angela Duckworth at the University of Pennsylvania who is measuring grit. Can you actually measure how much perseverance somebody has? And there was a score, you could actually take a test. And we're just starting to look at this. If you could measure that level of perseverance, we thought you could have a better idea of who would make it through. Or the way I'd like to think of it, how does that trade off some of these other characteristics?
Yeah.
So somebody, because everyone needs to be physically fit, but maybe somebody who has got more grit could absorb less physical standards and still make it through. Because sometimes we'd see it anecdotally when we talk to SEAL trainers, we'd say, can you tell me something about the people who don't make it through? And one of the things that came back several times is that this studs in high school didn't necessarily do that well at buds, the training. And we hypothesize is because if you've never failed
Yeah.
and had to overcome failure, it's really hard because everyone hits the wall. And you
Mhm.
have to be able to overcome that. Just like Angela Duckworth, when she's looking at spelling bee champions. The spelling bee champions weren't the smartest kids. You had to be really smart,
Yeah.
but it's very smart, like the top 2 quintiles of intelligence, but really high in the grit scale. So if you're really super smart, if your grit wasn't really high, it didn't matter how smart you were. You
Mm.
still wouldn't win the spelling bee. So it's interesting. There's a human psychology is fascinating from that perspective.
Yeah, that's amazing. I know Angela, she's the author of Grit, correct?
Yes.
That I will literally be reading that, like, right away. That sounds incredible, and I mean, I mean, from, like, a quantitative perspective, measuring intelligence has always been, like, ACT, but, like, how you actually measure grit, I feel like goes a long ways because, like you said, someone that's a stud high school athlete that goes to buds, but they've never failed really because they just dominated sports. I think that's a really interesting concept that grit can actually measure.
Yes. And there's some sports that had different impacts. Like some of that, the more individualistic sports at that time anyway, tended to be more predictive of
Wow.
success. And at that time was like MMA and wrestling and water polo, of course, was good. But it was like kind of the oddball sports, not like
Mm,
football, basketball, which a lot more people are involved with. But I think part of it is just the mental stress you go through. And also it's unusual, it's different, it doesn't just grab for popularity reasons people into the fold.
yeah. So we're kind of winding down here. We've talked a little bit more about like what has gone into like modeling projects that you worked on. I think that is super cool. I'm always a fan of talking about that. I also want to talk about like the future of like analytics. Just for people that are young that are wanting to get started in their career, are there specific industries you're more bullish on for like analytics specifically that you think people should consider checking out?
And that's an interesting question. I don't think there's any particular industries that are great or bad because there's data everywhere.
Yeah.
Every vertical is leveraging data and becoming more data driven. So some of this will depend, I think, for the individuals. What things do you enjoy doing?
Hmm.
And then once you get into an organization that is data driven, or maybe sometimes it's a group within the organization that's more data driven, to get in there, roll up your sleeves, join that
Yeah. Yeah.
team, or find a way to be a part of that team, and then try to make your boss and your boss look super successful with analytics. And a lot of times it means biting off small chunks at a time, quick wins,
Mm,
rather than trying to hit a home run with analytics. And so that's what I recommend for people just starting off. If they've got an analytics background already, that
yeah.
can help. But even if you don't, if you just love data and love numbers, to get attached to those organizations that are becoming more data driven, data
Mm,
informed. It could be more business intelligence groups. They're just trying to report and summarize data and take the opportunity while you're doing that to understand the why question. Cause to me, that's
mm,
a lot of BI and reporting describes what,
yep.
but then the question is why, or why are there changes over time? And that takes, you have to peel back that onion another layer to look at the data and try to understand it a little bit better. Because one of the best analysts I ever knew was a woman who worked for one of the Blues, Blue Cross Blue Shield,
That's
doing
cool.
fraud. And she was just in spreadsheets all the time, but she loved data. And she was just kind of poking around. She didn't know all the machine learning stuff, but she was just looking at data. And then she came to one of my courses. We started talking about it. I love just over lunch. I love the way she thought about the data. She was really trying to understand what was going on with some of the fraud. This was, I think, Medicare, not fraud, that she was seeing weird things in the data. And
Interesting.
so she was picking up how to do this at scale using machine learning techniques to speed up the process, because that's really the advantage. Because, if you look at a spreadsheet, maybe there's like, if there are like 10 columns in the spreadsheet you're analyzing, you could
Yeah.
do that. But if there's 1,000, forget it. It's going to take you forever. And that's what machine learning can do, is tell you, okay, focus on these. This is where the game is. Whatever techniques you're using. And then you can look at that, try to understand it better, visualize it, do the data storytelling you were telling before, tell your boss the insights you're seeing from the data, and help your company become more successful in a data driven way.
Ah, that's amazing. That's a great, great answer. I love like like the why. Like, why is this happening? Like, and just measuring it down and using machine learning to really hone
Yes.
in on that. And then just last question for you. You, Dean, you have been amazing. And like I have loved hearing about like analytics from you, like the projects you've worked on. So this has been great. And just last question. Like, what general career advice would you have for anyone that's wanting to stand out in their career and like do well in their career?
I think I alluded to a little bit before from a career trajectory standpoint. When you're starting with a company, if you're interested in data and trying to improve in analytics, I
Yeah.
mean, I would say there's two prongs. One is your own self learning and understanding. And I'll get to that in a moment. But the second part is it's just as important to interview your boss, or
Mm,
to understand who you're reporting to directly, uh, as much as it is being prepared for your role. Because I've, I hear such terrible stories about people who they position themselves well, but their boss is not either. And I don't mean just in terms of mentorship,
yeah.
but recognizing talent, giving you freedom and flexibility to do something that's interesting and creative. Whereas understanding, of course, that you've got to deliver for the company. So it's not like you're a grad student can do
Yeah.
whatever you feel like doing, but to help you become better and improve. So finding a good group to be involved with. And if you're in a group in the company where you're being stifled or there's a lot of
Mhm.
politics going on, if you can move out of that group into another group that's um, more, I guess, affirming and positive,
Yeah.
and will let you thrive more, that's tremendously important. And then from your own standpoint, read, and watch videos to uh, uh, there's a science to machine learning, which you can read from any books, or you go on Medium and get some decent material, or wherever, or take Udemy courses or those kind of things. But I think as much as that's valuable, it's also valuable to talk to people who have done it
Mhm.
and roll up their sleeves, because there's an art to it as well as a science. And the art doesn't get written down as much. And the art is tremendously valuable to see, what do you do when you hit this problem or that problem in the data? How can
Right.
you triage your analysis so you can be effective in delivering that model next week, or that analysis in a week, not in a month?
I love that. Well, Dean, thank you so much for joining us. It's been an awesome episode about like all things analytics. So thank you so much for joining us. We really appreciate it. Thank you so much.
Oh, really enjoyed it. Thanks so much for having me.